Today we are going to perform the experimental study of pressure distribution in a general bearing. Let us move to the demonstration part where we are going to perform the practical. Today we are going to study the frictional losses, coefficient of friction and pressure distribution in a general bearing. A general bearing is a type of sliding contact bearing used to support and guide rotating a shaft. The portion of the shaft that rotates inside the bearing is called the general. Here at the back side you can see this is the general bearing, right? Here is the shaft which will rotate when we will transmit the power, right? Then when a shaft rotates, a thin film of lubricating oil forms between the general and the bearing surface, reducing friction and wear. The study helps us understand the effect of load, speed and viscosity of bearing performance. Here we have provided lubricating oil, right? This is the oil. When rotational motion takes place between the shaft, the oil is directly connected inside the general and the bearing for the lubricating purpose. Now at the bottom we have provided weights, right? When the rotational motion takes place, the pointer starts to deflect. Here at the above we have provided pressure gauge and at the side we have provided the pointer, which will actually show us that when different weights are added on a rotating mass of the shaft, the pointer will start to deflect. The apparatus required are general bearing test rig, weight and hanger for loading. At the bottom we can see that, then tachometer, spring balance or torque arm, then stopwatch and lubricating oil. Now what we are going to do, we are going to check before starting the experiment. We are going to perform general bearing is properly lubricated with oil, then start the motor to rotate the general at a constant speed, then apply a known load on the bearing using the weight hanger. We have already provided a load on the bearing. Then allow the bearing to run for some time so that the oil film develops. Now let us start the experiment. Here we can see the shaft is rotating, right? Now as the speed increases, the pointer will try to deflect. Here we can see the deflection, right? Due to the weight hanger, how much it has been deflected when the shaft speed has been increased. This is the shaft, and as the speed increases, the deflection also increases.